Principle principle Principle: the basic theory of electrochemical corrosion requires an anode, a cathode, an electrolyte, and a flow of electricity between the anode and the cathode. The anode always corrodes in preference to the cathode. The smaller the anode area in relation to the cathode area, the faster the corrosion rate. An electrolyte is a solution containing ions which are particles bearing an electric charge. Ions are present in solutions of acid, alkali, and salts. Anodes and cathodes exist in all iron and steel metals. They are caused by surface imperfections, grain orientation, lack of homogeneity of the metal, variation in environment, localized stresses, Miller scale, and existing red iron oxide rust. What are the factors affecting corrosion? Exposure of the metals to air containing gases like CO2, SO2, SO3, etc. Exposure to metals to moisture, especially salt water, which increases the rate of corrosion. Presence of impurities like salt, for example NaCl. Temperature and increase in temperature increases corrosion. Nature of the first layer of oxide formed. Some oxides like Al2O3 form an insoluble protecting layer that can prevent further corrosion. Others like rust easily crumble and expose the rest of the metal. Presence of acid in the atmosphere. Acids can easily accelerate the process of corrosion. What are the types of corrosion? Some of the corrosion types include the following: corrosive corrosion. Whenever there is a difference in ionic concentration between any two local areas of a metal, a localized form of corrosion is known as corrosive corrosion can occur. For this form of corrosion mostly occurs in defined spaces, crevices. Examples of areas where corrosion can occur are gaskets, the undersurface of washers and bolt heads. All grades of aluminum alloys and stainless steels also undergo sleeve corrosion. This is mainly because of the formation of a differential aeration cell that leads to the formation of corrosion inside the crevices. Stress corrosion cranking can be abbreviated to SCC and refers to the cranking of the metal as a result of the corrosive environment and the tensile stress placed on the metal. It is often occurs at high temperature. It often occurs at high temperatures. For example, stress corrosion cranking of austenitic stainless steel is chloride solution. Intergranular corrosion occurs due to the presence of impurities in the grain boundaries that separate the grain formed during the solidification of the metal alloy. It can also occur via depletion of enrichment of the alloy at these grain boundaries. For example, aluminum-based alloys are affected by IGC galvanic corrosion when there exists an electric contact between two metals that are electrochemically similar and are in electrolytic environment. Galvanic corrosion can arise. It refers to the degradation of one of the of it refers to the degradation of one of these metals at a joint or at a junction a good example of this type of corrosion would be degradation that occurs when copper in a saltwater environment comes in contact with steel. For example, when aluminum and carbon steel are unheated and immersed in seawater, aluminum corrodes faster and steel is protected. Pitting corrosion is very predictable and therefore is difficult to detect. It is considered one of the most dangerous types of corrosion. It occurs at a local point and proceeds with the formation of a corrosion cell surrounded by the normal metallic surface. Once his pit is formed, it continues to grow and can take various shapes. The pit slowly penetrates metal from the surface in a vertical direction, eventually leading to structural failure if left unchecked. For example, consider droplet of water on a steel surface. Pitting will initiate at the center of the water droplet, anodic site.